So in this one, first you try to talk about your polarization. What do you mean by polarization, beta? Any idea?
Light frequencies ఉంటాయి సార్.
Light?
Light కి frequencies ఉంటాయి.
అవును.
సో సింగిల్ ఫ్రీక్వెన్సీ ఒకటే వైట్ ఫ్రీక్వెన్సీ ఉంటే it will be plain polarized light.
Okay. Light is a combination of what? Electric and magnetic field vector?
Yes, sir. Yes, sir.
Like say, if I'm taking the light like this, is a form, inco form like this. This is a combination of your electric field vector and magnetic field vector. Electric field vector is more dominant compared to your magnetic field vector.
Yes,
Unpolarized
sir.
light is being represented by like this. This is your dot and as well as of your cross. This is called as of your unpolarized light. Okay.
Yes, sir.
The phenomenon of restricting or the phenomenon of your blocking either the electric. Right now, if I'm taking the electric and electric field is more dominant. So the electric field vector is been moving in all the directions like this. If I make this line or this electric lines of the field to pass only in one plane, in one particular plane, isn't it? So that is called as of what? Polarization. Isn't it? The
Yes,
phenomenon
sir.
of your restricting the vibration in a particular plane is called as of your polarization. This light is called as of your unpolarized light. Intensity of this one is, say, for example, I0. I can polarize this one by making it to pass through a material called as of your polarizer. Okay, when this light passes through this one, the light which is been coming out is right now only with your arrow mark like this. Okay, the intensity of this will become how much for me, or I1. So that will become for me half of your initial intensity. That is nothing but I0 by 2. Isn't it? To analyze this one, again we are passing it through your another thing that is called as of your analyzer. So when it is passing through this one, if it is passing, there is a small vertical holes in this one like this, and even in this one like this. Only vertical vibrations of the light can pass through this one. Horizontal vibrations have been stopped. So outcome is right now completely polarized. So this one is your IR. So IR here is right now becoming for me your I1. So the process of your restricting the vibrations in a particular plane perpendicular to that one is called as of your polarization. Now we'll be solving the problems with the help of your Malus law. I hope you remember the Malus law, beta. I is equals to your I0 into your cos square theta. Isn't it?
Yes, sir.
I is equals to your I0 into your cos square theta. I0 is the initial intensity. R is nothing but the resultant intensity which is emerging out, and theta is the angle between the analyzer and as well as of your polarizer. Got it?
Yes, sir.
Sure. Let me give you an example. This is very important formula, beta. IR is equals to your I0 into your cos square theta. IR is equals to your I0 into cos square theta. You see this problem? Let's say, for example, if I say that calculate theta so that resultant intensity coming out of P3 is maximum. P3 is maximum. Let's say this is a question for me. This is your light. And here unpolarized light is been incident. Dot and arrow mark. Dot and arrow mark. This is called as unpolarized light. And it is being made to pass through a polarizer. Polarizer that one is right now for me P1. And there is another polarizer light now like this. This one is your another polarizer. This one is your P2, and it is making an angle theta with your vertical. Done better? And there is a third polarizer which is along this axis like this. And from this one, it is been rotated by an angle of your 90 minus of your theta. This is a polarizer P3. Clear?
Yes, sir.
Here P1 and P3 are crossed. P1 and P3 are crossed. And the angle between them is how much? 90 degrees. Because see, this is completely sleeping and this is completely vertical.
Yes,
This is
sir.
vertical, this is horizontal. So angle between 1 and as well as of your 3 is how much for me? 90 degrees. Incident,
Yes, sir.
the one which has been incident here is right now for me I naught. So this is a polarizer P1, this is a polarizer P2, this is a polarizer P3. Now what is the question is, calculate theta so that the resultant intensity coming out of this P3 is your maximum. Okay. Now tell me, from this I naught, the intensity which is coming here, I'm taking like say for example I1, and here I'm taking it as of your I2, and the one which has been coming out, I'm taking here as of your I3. Okay. Now tell me what is the value of I1 beta? I1 will be equal to half of that intensity, that is I naught divided by 2. And then,
Yes, sir.
whereas I2 will be equal to how much beta? I2 will be equal to your I1 into your cos square theta. So what is the value of I1? I1 is equals to your I naught divided by 2 into your cos square theta is your value of your I2. And then,
Yes, sir. Yes, sir.
now tell me I3. I3 will be equal to here how much angle we are rotated? 90 minus theta. So I3 will be equal to your I2 into your cos square. Angle between them is 90 minus theta. So I2 value is how much? Substitute the value of I2 from this one. So I2 value will be equal to your I0 divided by 2 into your cos square theta into your, this one is your cos square 90 minus theta. Can I write like this?
Yes, sir.
Cos 90 minus theta is equals to I0 by 2 into your cos square theta into sin square 90 minus theta is how much beta? Sin square theta.
Yes, sir.
Cos square 90 minus theta is nothing but how much for me? Sin square theta.
Yes,
What
sir.
we do is divide and multiply by 4 for this one beta. So if I divide and multiply by 4, this will become for me I0 divided by your 8 into, this will become for me 4 into your sin square theta into your cos square theta. Can I write like this?
Yes, sir.
So this will become for me your I0 divided by your 8 into your, this will become for me sin square 2 theta. This is your I3. What an idea.
Yes, sir.
Now when this will become maxima beta? I3 will be maximum. I3 will be maximum when sin 2 theta value is how much? 1.
Yes, sir.
That means a 2 theta value must be equal to how much? 90 degrees. That means
Theta
theta must
equal
be
to
equal to
45.
45 degrees.
Yes,
What an
sir.
area,
Yes, sir.
isn't it? So that is the way how do we get the questions based on this one for the given conditions. Okay, now?
Yes, sir.
Sure. Let me give you one more example. See this question. Like say there is one polarizer here. I'm representing the polarizer like this. And there is one more polarizer here. There is one more polarizer here. There is one more polarizer here. So totally how many polarizers? P1, P2, P3, P4. Okay. And the light which is being incident on this one. Say this is your unpolarized light. Dot and arrow mark. Dot and arrow mark. Intensity of this one is right now for me or I naught. My question is right now for me. What is the fraction of? What is the fraction of incident light? Incident light which comes out. which comes out. Okay, that means from P4, what is the intensity of light which has been coming out? That is my question. Provided the angle between P1 and P3 is 30 degrees, P2 and P3 is also 30 degrees, and P3 and P4 is also 30 degrees. Got an idea?
Yes, sir.
So here it is I0, like say here the intensity is right now for me I1, here it is like I2, here it is like I3, and here it is like I4. So I4 is coming out. So he's asking the fraction of incident light which has been coming out. Clear?
Yes, sir.
Now can you tell me what is the value of I1? I1 value will become how much for me beta? I0 by 2.
Yes, sir.
Directly passing. I2 will be equal to how much for me? I1 into your cos square 30 degrees.
Yes, sir.
So I1 value will become how much for me? I0 by 2 into your cos 30 is how much? Root 3 by 2. So it is
Yes, sir.
root 3 by 2 ka whole square. That means this will become for me 3 times of your I0 divided by how much?
8.
8. So this will be the value of your I2. Then I3 value beta. I3 value will be equal to your I2 into your cos square again 30 degrees. I2 value is how much for me? 3 times of I0 divided by 8 into your, again this one is root 3 by 2 ka whole square. So root 3 of whole square means 3. 3 3 is a 9. So it is 9 times of your I0 divided by how much better? 2 square is 4. 4 8 is a 32. This will be your I3. Then what will be your I4? I4 will be equal to your I3 into your cos square again 30 degrees.
Yes,
So
sir.
I3 will be equal to 9 times of your I0 divided by 32 into your cos 30 is again root 3 by 2 ka whole square. So
Yes,
this will
sir.
become for me, how much I am getting this
81
one?
by 64.
How much?
81 by
7, this one is
128.
3. 7 3 is a, sorry, 9 3 is a.
27.
So this is 27 times of your I0 divided by 32 into 4.
128.
128. So this will be your I4. So now what is asking
Yes,
the
sir.
problem is I4 divided by I0 is how much? Fraction. So it is 27 divided by 128. So this is your answer. Done?
Yes, sir.
Any doubt in this one?
No, sir.
So questions we'll be getting on this one is something like this only beta. Okay now?
Yes, sir.
Sure. So I'll give you one general formula you see. For 3 polarides, we'll be writing I3 will be equal to how much beta? I3 will be equal to your I0 divided by 2 into your cos square theta ka whole square. Isn't it? For 4 polarides, I4 will be equal to your I0 divided by 2 into your cos square theta whole cube. Ante kada?
Yes, sir.
Let's see. How many polarides are there? 1, 2, 3, 4. Okay, like this. So for n polarides, what I can write? For n polarides, I can use the formula IAN will be equal to your I0 divided by 2 into your cos square theta to the power of your n minus 1. No, no. So for n polarides, IN will be equal to your I0 by 2 divided into cos square theta n minus 1. Like say for example, if I'm talking about for 2 polarides, what will be the answer?
I by 2 cos square theta raised to 2.
Yeah,
Raised to 1.
equals to I0 by 2 into, here in the place of n you keep the 2 minus 1. So this will be equal to I0 by 2 into your cos square theta. So this is the value of your I2.
Yes,
Got
sir.
it? This is for 3 polarites, and this is for your 3 polarites, and this will be for 4 polarites. And this is your general formula.
Yes, sir.
This is your general formula. Polarites question chances unnai, very important topic also.
Yes,
Okay,
sir.
Next one is one small topic in this one more. That is about your Brevister's law. Gurtunda?
Yes, sir.
Brevister's law. Okay, so when light of certain frequency is being incident on this one like this, and this was completely unpolarized light, dot and arrow, dot and arrow, dot and arrow. This angle is known as angle of polarization represented by IP. This light from here, it will get reflect like this, and one amount of light will get refract like this, isn't it? So in this one, the light is completely polarized beta, only will be getting right now dot. So this one is completely polarized, reflected ray, completely polarized, isn't it? This one is what? A reflected ray. So he asks you, reflected ray is completely polarized, whereas a refracted ray is partially polarized. Refracted ray is partially polarized. Partially polarized. At a particular angle called as polarizing angle, the angle between the refracted ray and reflected ray is exactly 90 degrees. At this particular angle, then reflected ray is completely polarized and refracted ray is partially polarized. This one is also your IP. I hope you remember the formula of Brevister's law. Mu is equals to your tan of your IP. Mu is equals to your tan of your IP. I got it just from the Snell's law beta. See here, from Snell's law, mu1 into your sine of your IP will be equal to your mu2 into your sine of your R. Isn't it? Mu1 is right now for air, mu1 is nothing but 1, and mu2 is nothing but equal to your mu. Now see, this total angle will be equal to how much better? Now see here right now, this angle if I am writing right now for this one, this is your angle of your refraction R. This total angle must be equal to 180 degrees. So I can write here IP plus 90 plus R must be equal to 180 degrees. So from this one I can write IP plus R is equals to 90. So R will be equal to 90 minus of your IP.
Yes, sir.
Isn't it? So this value substitute here, mu1 is right now for mu1 into sine into your IP is equals to mu2 is mu into sine R is equals to 90 minus of your IP. Sine 90 minus theta.
Cos theta.
So this will be equal to mu into cos of your IP. So mu is equal to sine by cos, that will be equal to tan of your IP. Got an idea?
Yes, sir.
So I'm asking the theoretical questions here right now in this one. Key at what particular angle, who is completely polarized and who is partially polarized? Reflected ray is completely polarized and the refracted ray is partially polarized.
Partially polarized.
Clear?
Yes, sir.
No doubt in this one?
No, sir.
Then one more important relation which you need to remember in this one is about your concept of your interference. Formulas gurtunaya? Interference means what beta? Superposition of more than 2 or 3 waves is known as of your
Interference.
Hona kada? So
Yes,
like say
sir.
from this one, like say here there is a source S1 and here there is a source of your S2. From this one, the light is been going somewhere here and here this light has been going somewhere at this point P, they are getting interference. Like say this is traveling a distance x1, this is a traveling distance of your x2, amplitude of this one is a1 and amplitude of this one is also equal to like say for example, almost all same amplitude part of a relation, isn't it? If they have been superimposed on each other right now, okay, so the amplitude right now for me A2, path difference are y1 plus y2 part of relation. Then what is happening right now in this one? Can you tell me? The ray of light has been right now getting superposed,
Yes, sir.
isn't it? So if I am superposing these two waves from which way have been coming, the first one wave equation right now. The first wave equation is y1 is equals to your a1 into your sine of your omega t minus of k into x. అదేవిధంగా y2 will be equal to your a2 into your sine of your omega t minus of your k into your x, isn't it?
Yes, sir.
If we are superimposing both of them, y is equals to y1 plus of y2, we get the resultant intensity from this one. So that resultant intensity is given by the formula of your given conditions. That means from this one, we'll be writing two formulas beta. So this is the principle of superposition, y is equals to y1 plus y2. The first formula what we get is how do you calculate the resultant amplitude? A resultant is equals to your under root of your a1 square plus of your a2 square plus 2 times of your a1 a2 into your cos of your phi. So what is phi beta? Delta phi is known as phase difference. Phase difference is equals to
Is
2 pi
different, sir.
by lambda into your delta x. So this is a relation between phase difference and path difference. Delta x is a path difference. Delta phi is known as of your phase difference. And we know that intensity is directly proportional to the square of your amplitude. So removing the proportionality constant, I is equals to some k into your a square. So if I'm writing the amplitude in terms of intensity, I'll be writing the resultant intensity will be equal to your, this will be your I1 plus I2 plus this one is 2 root of your I1 I2 into your cos of your delta phi. Antena?
Yes, sir.
Now in this one you see that if amplitudes are same, if A1 and A2 is equals to like say for example of your A I'm taking, okay, if, isn't it? So that time the resultant intensity will become how much better? A resultant will become for me 2A into your cos of your delta phi divided by 2. The same way, if intensities are same, if I1 is equals to I2 is equals to your I, then resultant intensity will become how much for me better? 4 times of your I naught into your cos square delta phi by your 2. This is also very important formulas bit. Direct formulas such as Chana Sarli JE means direct questions on the intensities and as well as of your amplitudes part of relation. So resultant intensity, both of them are same, and amplitude, if the amplitudes of both of them are right now remaining for me the same. Resultant formula is AR is equals to this much and IR is equals to this much. Clear, beta?
Yes, sir.
Sure. Now at point P beta, when these two waves are being meeting, we may be getting a bright point or dark point. That bright and dark points are known as what beta? Constructive interference or destructive
Destructive
interference.
interference.
So if I'm talking about your interference in this one, in interference, we may either get a constructive interference, a bright point, or we may be getting a destructive interference, isn't it? If I'm talking about your constructive interference, which is also called as a what? Bright point. Which is also called as a what? Bright point. Proceed. Condition for the bright point beta. This is your constructive interference. So first formula which you should remember in this one is phase difference. Delta phi value will become for me 2n into your pi. Why? It depends upon intensity. Na? The intensity of formula kya hai mere paas? I is equals to your I1 plus I2 plus 2 times of root I1 I2 into your cos of your delta phi. Isn't it? This
Yes,
intensity will
sir.
become maxima when this cos delta phi value is maxima. So what is the value? What is the maximum value of your cos means at a value of phi is equals to 2n into your pi.
Yes,
Isn't it?
sir.
So in the same way, delta phi is equals to how much for me? 2 pi by lambda into your delta x is equals to 2n into your pi. This 2 pi will get cancelled. So path difference I'm getting delta x is equals to n into lambda. So when delta x is equals to n into lambda, we are getting the constructive interference. Got it?
Yes, sir.
So for this one, resultant amplitude will become how much for me here? A net will be equal to your, if value of the cos phi value is 1, A net will be equal to your A1 plus A2. If A1 and A2 are same, if A1 and A2 is equals to your A net will be equal to your how much for me? 2 times of your A. Clear?
Yes, sir.
In the same way, intensity beta. Intensity कितना होगा बताओ? Fourth one, intensity will be equal to your I is equals to your root of your I1 plus root of your I2 ka whole square. Because cos value I'm taking it to be the maximum, isn't it? So if
Yes, sir.
I1 is equals to I2 is equals to I naught, then net intensity will become for me 4 times of your I naught, which is maximum,
Yes, sir.
isn't it? See, all this I'm writing from this basic formula. I is equals to your I1 plus I2 plus 2 times of root I1, I2 into cos of your delta phi. The maximum value of cos delta phi must be equal to how much beta? Plus 1. So for what value of the cos phi value it will become plus 1 means it will become for me how much for me? 2n into your pi. Clear?
Yes, sir.
So constructive interference key. What is the path difference? Delta x is always equals to your n lambda. Clear? The next one
Yes, sir.
is destructive interference. Destructive interference. That means a dark point. Destructive interference is nothing but for me your dark point. Okay. So for this one, what is the condition beta? Phase difference delta phi is equals to your 2n plus 1 into your pi. Cos 180 minus 1 kada.
Yes, sir.
So starting from your n value is equals to how much for me? How much I should keep the n value? 0.
Yes, sir.
So this will become how much for me? Pi. Cos phi will be equal to how much for me? Minus 1. So that will be getting the dark point. So I can write for this one, phase difference delta phi will be equal to your 2 pi by lambda into your delta x is equals to your 2n plus 1 into your pi. So this pi will get cancelled. So path difference formula is delta x is equals to your 2n plus 1 into your lambda divided by 2. Antena?
Yes, sir.
So this is the path difference formula, very important. So path difference is equals to your 2n plus 1 into your lambda by 2. In the same way, what will be your A net? If I'm keeping the value cos 180 will be getting minus. That means A net value will become for me A1 minus A2. If A1 and A2 are 0, if A1 and A2 is equals to your A, then A net will become how much for me? 0 kada?
Yes, sir.
In the same way, how I got this A net beta? We are getting it from the formula A net is equals to under root of your A1 square plus A2 square plus 2 times of A1, A2 into your cos of your delta phi. Now delta phi value you keep minus 1. And a cos 180. Cos 180 is minus 1. So it is A1 square plus A2 square minus 2 times of A1, A2. So it is A minus B whole square. So root will get cancelled. So A net is A1 minus A2. And if amplitudes
Yes,
are
sir.
same, A net value will become for me 0. In the same way, intensity, I net will be equal to your, this will be root of your I1 minus root of your I2 ka whole square. Isn't it? Even in this condition, if I'm saying that if I1 is equals to I2 is equals to your I naught, then net intensity at the center of the screen will be equal to 0. Got it? So this is called as of your minima and this one is called as of your maximum. बात clear
Yes,
है?
sir. Yes, sir.
Very important. Already regularly questions पूछा जा रहा हुआ है basically. Destructive interference, constructive interference के लिए condition क्या होगी? When it will become maxima, when it will become Fermi or minima part of relation. ये पूरे already पूछ चुका है basically. You need to remember, and this is a small chapter where you can do it very easily, scoring chapter from this given condition.
Yes, sir.
Isn't it? PYQs आराम से कर लो, निकल जाता आराम से बेटा, कोई ज्यादा दिक्कत नहीं होती. Purely formula based है, ज्यादा knowledge लेने की भी जरूरत नहीं है इसमें. ठीक है?
Yes, sir.
The next one in this one which you should remember is your Young's double slit experiment ka experiment. Young's double slit experiment. This experiment shows the wave nature of your light beta. Young's आपने क्या बोला था कि light also behave as of your wave nature so that it is having the phenomenon of your bending at the sharp edges. उन्होंने क्या लिया, एक छोटा सा cardboard लिया ऐसा with the 2 holes and यहाँ पर एक screen रख दिया and he called this one as S1 and this he called as of S2. हम लोग डिटेल में नहीं जा रहे ज्यादा. तो ये हो गया इसका सेंटर. तो यहाँ से एक वेव जाएगी इस तरह से and it is meeting somewhere here. And यहाँ से एक wave जाएगी इस तरह से, it is meeting somewhere here right now. So this point wherever it is meeting, it may be the point of constructive interference or destructive interference. So if this is making an angle theta, then इसमें से बताओ कौन सा path difference ज़्यादा है बेटा? Isn't it? S1P is more or S2P is more? S2P is more.
S2P.
तो यहाँ से आप एक ऐसा perpendicular drop कर लीजिए. So this extra distance is only known as path difference. अगर ये theta है ना बेटा इसमें, तो ये कितना हो जाएगा बेटा 90 माइनस टीटा. तो ऑब्वियसली ये भी कितना बन जाएगा टीटा. तो ये देखो टीटा है यहाँ पर 90 डिग्री. मैं इसको ऐसा वर्टिकल लगा रहा हूँ बेसिकली. तो ये टीटा है, तो ये कितना बन जाएगा 90 माइनस टीटा. अगर ये 90 माइनस टीटा है, ये 90 है, तो ये कितना बन जाएगा टीटा. दोनों की डिस्टेंस कितनी हो जाएगी स्मॉल डी. एंड कैपिटल डी इज द डिस्टेंस बिटवीन द स्क्रीन एंड एज वेल एज ऑफ योर स्लिट. ठीक है. डेल्टा एक्स को अगर रिजॉल्व कर रहे हो बेटा, इस डी को देखो यहाँ पर कंपोनेंट ऐसा कुछ बनेगा. ये वाला पॉइंट है S1 और ये वाला पॉइंट है S2. दिस इज योर डी एंड दिस इज मेकिंग एंगल हियर थीटा. ऐसा रिजॉल्व करोगे तो ये बन जाएगा मेरे पास d cos थीटा और ये बन जाएगा मेरे पास
d sin थीटा.
तो डेल्टा एक्स विल बिकम हाउ मच फॉर मी, d into your sin थीटा. सो पाथ डिफरेंस कितना बन गया, डेल्टा एक्स इज इक्वल्स टू योर d into your sin थीटा. Isn't it? When theta is very small, when theta is very small, so I can approximate sin theta to be your tan theta.
Yes sir.
So point P मान के चलो सेंटर से यहाँ पर कहीं पर गिरा y पे. ठीक है. So tan theta वैल्यू अगर लिख रहा हूँ तो पाथ डिफरेंस का फॉर्मूला कितना बन जाएगा, डेल्टा एक्स इज इक्वल्स टू योर d into your tan theta. यानी ये बन गया मेरे पास डेल्टा एक्स इज इक्वल्स टू डी इंटू tan theta वैल्यू विल बी इक्वल टू योर y डिवाइडेड बाय कैपिटल D. Isn't it? So ये हो गया मेरे पास path difference for the YDSC. Delta x is equal to d into y divided by d. Y may be the point of your bright point or dark point. ठीक है ना? तो
yes,
ये देखो अगर मैं bright point के लिए लिख रहा हूँ तो क्या होगा, अगर dark point के लिए लिख रहा हूँ तो क्या होगा. For bright fringe or bright point, you know that path difference is how much? Bright point is nothing but called as what beta? Constructive interference.
Yes sir.
For constructive interference delta x कितना होता है, n लैम्बडा होता है.
Yes
डेल्टा एक्स की वैल्यू यहाँ पर डाल दो, d into y divided by capital D is equals to n into lambda. यानी y कहाँ पर बना, y is equals to n into lambda into capital D divided by your small d. So y nth bright point is being found at a position of your n into lambda into your capital D divided by small d. Clear है? First,
yes,
first bright, second bright, dark bright में n is equals to, you can go and take 1, 2, 3, will get the answer for that. उसी तरह से if I'm talking about your dark fringes, dark fringes बताइए कहाँ बनेगा बेटा. डेल्टा एक्स का पाथ डिफरेंस कितना है मेरे पास, d into y divided by capital D. डेल्टा एक्स का वैल्यू कितना होता है बेटा, 2n minus 1 into your lambda divided by 2 is equals to d into y divided by capital D.
yes sir.
n की वैल्यू कहाँ से स्टार्ट कर रहा हूँ, 0 की 1
sir.
The value of n is equals to 1, 2, 3 ऐसा. अगर यहाँ पर प्लस ले रहा हूँ ना तो स्टार्ट फ्रॉम 0. ओके.
yes sir.
तो y की वैल्यू कहाँ बनी, y nth dark is formed at a position of 2n minus 1 into ये कितना बन जाएगा बेटा, y this will be equal to lambda, तो वैसे ही है यहाँ पर, so it will be your lambda into capital D divided by
2 dy.
I'm so small. This is the position of your second dark. This is the position of your nth dark. This is the position of your nth dark point. And this is the position of your nth bright point.
Bright point, yes.
This is your nth bright point. ठीक है?
Yes sir.
The next one, and again one more important term, fringe width क्या होता है? Fringe width. फ्रिंज विड्थ कैसे रिप्रेजेंट करते हैं बेटा, बीटा से, इस तरह से। फ्रिंज विड्थ इज नथिंग बट द डिस्टेंस बिटवीन two consecutive or two successive bright or dark fringes is known as of your fringe width bit. ठीक है ना?
Yes, sir.
So what is a fringe width? Distance between two successive bright or dark fringes. Bright or dark fringes. जैसे मान के चलो बीटा इज इक्वल्स टू कैपिटल डी इंटू लैम्बडा डिवाइडेड बाय स्मॉल डी। एंगुलर फ्रिंज विड्थ भी होता है इसके अंदर, एंगुलर फ्रिंज विड्थ का भी फॉर्मूला वेरी इंपॉर्टेंट बेटा। सो थीटा इज इक्वल्स टू लैम्बडा डिवाइडेड बाय स्मॉल डी।
Yes, sir.
So beta is equals to capital D into lambda divided by small d, and theta will be equal to your lambda into d. Very very important formula beta, fringe width and the angular fringe width का formula.
Yes, sir.
अगर YDSC is immersed in water बेटा, तो जब क्या हो जाएगा? If YDSC is immersed in water, fringe width की वैल्यू क्या हो जाएगी? बीटा डैश विल बी इक्वल टू, कैपिटल डी चेंज नहीं होगा, वेवलेंथ चेंज हो जाएगा, स्मॉल डी चेंज नहीं होगा। ओके, लैम्बडा डैश कैसा हो जाएगा बेटा? म्यू इज इक्वल्स टू योर सी बाय वी होता है रिफ्रैक्टिव इंडेक्स, दैट इज इक्वल्स टू योर, दैट मींस म्यू इज इनवर्सली प्रोपोर्शनल टू योर वी, that is inversely proportional to n into lambda. So I can write here mu1 by mu2 is equals to lambda 2 divided by lambda 1. mu1 is nothing but what? Air के लिए 1 हो जाएगा, mu2 is mu, this will be equal to lambda dash divided by lambda. तो lambda dash की वैल्यू कितनी आ गई? Lambda dash is equals to lambda divided by mu.
Yes, sir.
From the ray optics. तो fringe width का फॉर्मूला क्या गया? Beta dash is equals to d into lambda dash is lambda divided by small d into mu. देखो कैपिटल डी स्मॉल डी इंटू लैम्बडा इज नथिंग बट व्हाट बेटा? फ्रिंज विड्थ इन एयर, तो हो गया फ्रिंज विड्थ इनटू योर एयर डिवाइडेड बाय योर म्यू। So when it is immersed in the water, it will become for me, यानी जो fringe width in air में था, that will become 1 by mu times in the water.
Yes, sir.
They are very important point, but so when it is immersed in the water, fringe width will be changing by an angle of your how much for me? By fringe width will be changing by 1 by mu times of your v. ठीक है?
Yes, sir.
Sure. Next one is optical path. Like say when you see the 3D movies, 2D movies, we use the glasses. उसके ऊपर छोटा सा एक प्लास्टिक पेपर लगा हुआ रहता. So when light
Yes,
is been passing through any sheet of refractive index mu and thickness t, then उसको हम लोग जो distance travel करता है उसको हम लोग क्या बोलते हैं? Optical path बोलते हैं. The light which has been traveled in the thin sheet of your paper, which is having a refractive index, that is called as of your optical path, that is given by the formula mu into t. Mu is refractive index and t is your thickness.
yes, sir.
ठीक है? यहाँ से यहाँ तक ये जो होता है ना, t is nothing but your thickness. डायरेक्ट फॉर्मूला याद रख लो फिलहाल के लिए. ऑप्टिकल पाथ मतलब when light is passing through a thin sheet of your plastic paper, which is having a refractive index of your mu, optical path length is given by the formula mu into your t part of relation.
Yes, sir.
Sure. This is very important. But in YDSC, if a small, thin, transparent sheet is kept in front of one slit, तो जब क्या होगा? तो ये अपना YDSC था ना, ऐसा एक YDSC था और यहाँ पर अपने पास स्क्रीन था, है कि नहीं? दिस वन वाज ऑफ योर सेंट्रल मैक्सिमा, यहाँ से रे ऑफ लाइट ऐसा जा रही थी, फिर यहाँ से रे ऑफ लाइट ऐसा जा रही थी, एंड यहाँ पर इंटरफेरेंस था. ये S1 था, ये S2 था, ये स्मॉल d था, डिस्टेंस बिटवीन देम, और इन दोनों के बीच में कैपिटल D, है कि नहीं? अब अपन क्या बोल रहे हैं? यहाँ पर S1 की जगह एक थिन शीट ऑफ पेपर ऐसा कुछ रख दिए जिसका रिफ्रैक्टिव इंडेक्स है म्यू और थिकनेस है यहाँ से यहाँ तक का t और रिफ्रैक्टिव इंडेक्स है इसका म्यू. तो जब जो सेंट्रल मैक्सिमा पड़ रहा था ना, दैट विल शिफ्ट इन द अपवर्ड डायरेक्शन. तो सेंट्रल मैक्सिमा अब कहाँ पर पड़ेगा? यहाँ पर. डेल्टा x इज इक्वल्स टू 0. क्लियर है?
Yes, sir.
सो अगर जब शीट रखते हैं तो सेंट्रल मैक्सिमा सेंटर से शिफ्ट होके कहीं ऊपर जा रहा है, तो कितना शिफ्ट हुआ अगर वो पूछा तो हम लोग वो निकालना चाहिए जरूर, वेरी इंपॉर्टेंट कंडीशन में। तो इसका फॉर्मूला क्या है, y इज इक्वल्स टू योर कैपिटल D इंटू योर थिकनेस T इंटू म्यू माइनस 1 डिवाइडेड बाय स्मॉल d। डायरेक्टली फॉर्मूला याद रख लो, डेरिवेशन की भी जरूरत नहीं है। So अगर कोई थिन शीट ऑफ योर माइका पेपर ऑफ हैविंग रिफ्रैक्टिव इंडेक्स मिनिमम थिकनेस हैज बीन केप्ट एट S1 पे रखा तो ऊपर गया, S2 पे रखा गया तो नीचे जाएगा, isn't it? So there is a shift in the fringe, कहाँ पर, ऊपर, क्योंकि हम लोग ने शिफ्ट थिन शीट ऑफ पेपर कहाँ पर रखा, S1 पे रखा, तो सेंट्रल मैक्सिमा जो सेंटर पे बन रहा था अभी वो ऊपर बन रहा है, तो कितना ऊपर शिफ्ट हुआ अगर पूछा तो y इज इक्वल्स टू कैपिटल D इंटू T इंटू म्यू माइनस 1। कितने
Yes,
नंबर
sir.
ऑफ फ्रिंजेस शिफ्ट हुए, मतलब क्या लिखोगे, n इज इक्वल्स टू योर y डिवाइडेड बाय बीटा। सो n रिप्रेजेंट्स में व्हाट, नंबर ऑफ फ्रिंजेस शिफ्टेड, कितने शिफ्ट हुए, नंबर ऑफ फ्रिंजेस, नंबर ऑफ फ्रिंजेस व्हिच आर बीन शिफ्टेड, क्योंकि सेंट्रल मैक्सिमा शिफ्ट हो गया है तो ऊपर इससे पहले जो डार्क एंड ब्राइट पड़ रहा था वो भी शिफ्ट हो जाएगा ना बेटा, तो वो कितना बना, n इज इक्वल्स टू योर y इज इक्वल्स टू योर कैपिटल D इंटू योर T इंटू योर म्यू माइनस 1 इंटू योर बाई डिवाइडेड बाई कैपिटल D डिवाइडेड बाई बीटा। बीटा का फॉर्मूला क्या होता है बेटा, बीटा इज इक्वल्स टू कैपिटल D इंटू लैम्बडा डिवाइडेड बाई स्मॉल d।
Small d, yes.
कैपिटल D क्या होगा, स्मॉल d चले गया तो कितना बन रहा है, mu minus
Q
1
minus 1 into
density
T by D.
divided by lambda. So this will be the
Lambda.
formula for. Clear है?
Yes, sir.
Very important relation. So the number of fringes shifted can be directly calculated by the formula n is equals to mu minus 1 into T divided by lambda.
Yes, sir.
ठीक है?
Yes, sir.
वेरी इंपॉर्टेंट है बेटा, VDSC पे आज कम से कम आप 2-3 या 10 प्रॉब्लम्स तो भी करो, और पोलराइजेशन के भी प्रॉब्लम्स करो अच्छे खासे, दैट विल हेल्प
Yes,
यू,
sir.
बिकॉज़ डायरेक्टली फॉर्मूले बेस्ड प्रॉब्लम्स आते हैं इसके अंदर, ज्यादा कुछ भी नहीं होते, थोड़े प्रॉब्लम्स, बेसिक प्रॉब्लम्स अगर प्रैक्टिस कर लोगे देन 90% यू कैन डू द प्रॉब्लम्स रिलेटेड टू दिस वन।
Yes, sir.
ठीक है ना?
Yes, sir.
डायफ्रैक्शन के कल की क्लास में कर लेंगे, तो अभी तो टाइम नहीं है मेरे पास भी।
Okay, sir.
ठीक है ना, चलो,
Yes.
बाय।
Yes, sir.